Okay, this is lesson 5.3, and this is about surveys and questionnaires. This unit's fairly definition heavy. Apologize for that. It's usually a little bit more fun in class, but we got to work with what we've got, and what we've got is online videos. So let's get started. Terminology. A representative sample. When we're designing a survey or a questionnaire, we want a representative sample. So what's a representative sample? Well, it's a sample that's typical of the entire population. If the sample is not representative, it's called bias. And survey results can be invalid. Sample size. Sample size. In a survey, sample size can affect the results. If the sample is too small, survey results might not be reliable. If it's too large, the survey may cost a lot and be difficult to conduct. Sample size is how many people you're actually giving the survey to. So for example, if we wanted to collect data about the entire school, we're probably not surveying the entire school. If we were, it'd be called a census. What we would do is we'd pick a sample. We'd pick some grade 9, some grade 10, some grade 11, some grade 12s, maybe a couple of returning students, and if it's about school life, maybe you're asking staff members as well. But you're picking a group to represent the entire school. And who you survey is called your sample. How many is the sample size. When you're determining your sample, a lot of the word sample here, the representative samples are going to come from using random techniques. So we have 4 sampling methods that are random, and these are going to provide representative samples. Random just means they have an equal chance of being selected. That doesn't mean I'm going to pick someone from the class randomly and then you pick the person you're sitting next to. That's not random. If you're the one picking, like you get to decide, that's not random. If you let chance decide and everyone has an equal chance, that's random. So the first type of method is just random sample. To get a random sample, if I wanted to pick somebody from the class, I might take everybody's name, put it in a hat, shake it up, draw one out. That person was chosen at random because everybody's name had an equal chance of being pulled from that hat. Unless there's 2 people with the same name and then whatever. 2, stratified random. In stratified random sampling, the population is grouped and a few people are picked from each group. So for example, if we were surveying the entire school and we wanted a sample, we might group the school into grade 9s, grade 10s, grade 11s, grade 12s, take all the names from grade 9, put them in a hat, pick a few out. Same with 10, same with 11, same with 12. That's stratified random sample. Cluster random sample. That's where the population is organized into groups and one entire group is chosen. So maybe we arrange the school into grade 9s, grade 10s, grade 11s, and grade 12s, and we put the numbers 9, 10, 11, 12 in a hat, and we pull one of the numbers out, and if we get 10, we're surveying all the grade 10s. Last one is called systematic random sampling. In a systematic random sample, every nth individual is selected. What's that mean? Well, that means if you need to survey 40 people and the school has 400, you're going to survey every 10th person. So what that might mean is you're taking a list of the entire school's names from alphabetical order or random order, like you have a computer-generated random order, and you pick every 10th person on the list. That's a systematic random sample. Non-random techniques. Non-random techniques will not necessarily provide a representative sample. The thing about non-random is they're much easier to do. Representative sample. The first one's called convenience. I spelled convenience wrong. I think there's no I there. I've already written it. Convenience. Individuals who are easy to sample are chosen. So same example. There's a school of 400. We want 40. Maybe there's 28 people in your class. You survey all 20 of those people. You walk out into the hall. You start picking people out of the hall because they're right next to you. Maybe you only get 6. Then you go for lunch with 6 of your friends. Boom. There's your 40. That's convenience sampling. Judgment sample. This is the example where people think they're doing random sampling because they're just picking and they're choosing who they're going to survey, and they think they're doing it randomly. Like in the classroom, maybe you say eeny, meeny, miny, mo, and you point to somebody and say mo, and you pick that person. That's not really random. That's still you picking. You knew where mo was going to be. That's a judgment sample. Last one's volunteer sample. That's where you say, hey everybody, who wants to do my survey? And the people that, oh boy, I just realized. There we go. Convenience, judgment, volunteer. Volunteer sampling, that's where you say, hey everybody, who wants to do a survey? Whoever says, I'll do the survey, and fills in the survey, that's your sample. That's a volunteer sample. Okay, let's work with sampling techniques. A town has a population of 20,000. The town council conducts a vote at a public meeting about constructing a new ice hockey rink. 50 people attend the meeting. 40 of the people at the meeting vote in favor of the hockey rink, and council decides to build an ice hockey rink. Since 80% of the people support the data. So what percent of the meeting voted for the rink? 80%. What percent of people in town attended the meeting? Well, that's 50 people out of 20,000. That's 0.0025, which is 1/4%. Question is this sample representative? No, it's not. Less than 1% voted. And it was a non-random volunteer sample. For something to be representative, we want about 10% as a sample size, and we want a random sampling technique. If we don't have either of those, there's no way this is representative. If you have a random sample and something close to 10%, then you got a shot. But not with less than 1% and a non-random sample. All right, let's flip the page. Bias. Bias occurs when the results of a survey do not reflect the entire population. One way we can have bias is by asking a bias question. A bias question restricts people's choices or uses words that could influence people to answer a certain way. For results to be valid, survey questions must be unbiased. So here's 5 examples of bias. Leading question. Leading question contains wording or information to elicit a specific response. Loaded question, when suggested answers are provided. For example, there might be multiple choice and you get to pick. Response bias is when people intentionally lie to give false information. Non-response bias is when people fail to respond to one or more questions. And sampling bias is the one we just talked about, when you have a non-random sample. So how do you avoid these? How avoid? Question. Well, You avoid the first two by writing good questions. Don't lead somebody to pick something. Like say, I really like the color pink. What's your favorite color? People may be more inclined to say pink because they want to have that in common with you. Or don't say, what's your favorite color? Blue, red, green, or pink? Problem with that is it limits your choices and you're more likely to pick one of those four colors even if it's not your favorite color. You need to provide all options. How do you avoid response bias and non-response bias? You survey anonymously. People will intentionally lie or give you false information if you ask them face to face. They're going to give you an answer to the question that's more pleasing rather than necessarily the truth. Also, people may not respond to your questions if they think that you are going to judge them based on their answer. And the last one, non-random sample. Well, have a random sample method. Let's take a look at an example. People walking by in the mall were asked, we harm the planet when we use pesticides on our lawns. Should the government ban all residential pesticide use? Will the survey results be valid? Justify your answer. The answer is no, they will not be valid. And the reason why is, well, this statement. We harm the planet when we use pesticides. That's a leading question. Also, people walking by in the mall. What's that mean? Well, that means that's a non-random sample. You may think, well, that's kind of random because who knows, anyone could be at the mall. The problem with this sample is all these people that are in the mall at this time may have something in common. Like if you were asking at, say, 10 a.m. on a Tuesday, the people that you're going to get at 10 a.m. on a Tuesday are not the same as the people you're going to get on the weekend, necessarily. So this is a convenient sample. So because we have a leading question and a non-random sample, we do not have good survey results. How could this be improved? Well, we could rewrite the first sentence. And use a random sample method. What do I mean by rewrite the first sentence? Well, instead of we harm the planet when we use pesticides on our lawns, we could just ask, should the government ban all residential pesticide use? Last example. About 4,000 people visited a large sports equipment store during its annual sale. The store surveyed 100 customers after they paid for their purchase. An employee recorded their answers. Why are the survey results invalid? How could they be improved? To test the survey, ask yourself these questions. Good sports equipment can greatly improve performance. How much do you spend on sports equipment each year? $200 or less, $400 to $600, $800 to $1,000, $200. Whoa, I read these out of order. $200 to $400, $600 to $800, or more than $1,000. So basically, they're giving you a range of between $0 and more than $1,000. How much do you earn per year? Less than $1,000 or $10,000. Between 10 and 20, 20 and 40, 40 and 60, 60 and 80, more than 80. So, 100 customers out of 4,000. Well, sample size says 100 out of 4,000 is 2.5%. We want approximately 10%. Therefore, they need to survey more people. Is the sample representative? Well, it says that they only asked people who made purchases. So no, it's not, because we only asked purchasers. What's that going to do? Well, that's going to skew up the answers to this question because they already spent money on sports equipment. So if you bought, I don't know, a pair of $200 skates, you very much can't claim less than $200 because, well, you just spent $200. Also, they could use a random sample. Example, a systematic random sample. Of every 10th person. Every 10th person would get you 10%. So as they walk out of the store, ask every 10th person. If you provide an incentive, like a gift card or something, they'll likely fill in your survey. Are the survey questions unbiased? Well, question 1 is definitely a leading question. Because it says good sports equipment can greatly improve performance. Also, question 2 may lead to response bias. When you verbally ask somebody how much money they may inflate that amount. Finally, was the collection method appropriate? Well, kind of going into the response bias here. Never ask survey questions verbally. Always written and anonymous. All right, that was a lot of writing. That's it for the second lesson, 5.3, Surveys and Questionnaires. I'll see you next time.